All right, so this is a brief template of what we have for what our SBA could look like for us. Based on the minimum and based straight from the mark scheme here. In fact, I copy and paste some stuff from the mark scheme that was over here. Let's make this a little bit bigger so you can see it fit the width, you know. So I cannot follow what they have here. I know they want to see flow charts. I know they want to see a trace table. I know they want to see the program executing, and that would be screenshots and things like that. And I know that how they actually want to get the code. In our case, most of us, it's optional still, most of us will be using the graphical programming language Flowgorithm that we have been using since Form 3 all the way up to here. It's a real cool teaching tool. Well, I guess all I see it already. And it's more or less like you can be able to draw a flowchart and execute it. So that's why I call it a graphical programming language, right? So let me jump straight into it, right? So what I'm going to do, I'm going to save a copy of this document, right? And I'm going to start solving a hypothetical problem, all right? So save a copy, demo. All right, so I'm saving this as a demo, and I'm definitely going to post these files for all the fellas, right? So what I have here, I'm gonna make this a little bit bigger so people could see it. We had to solve some sort of problem, right? But in doing the documentation for SBA, we have to inform our viewers about the problem that we're solving. Now I know some people might have all right, so that we can do. Might have sorry for stalling so much. I was just doing some editing, right? They might have scenarios that's specific to them. I think I have one group that's doing cricket statistics or something like that. And what could be an interesting problem for them to solve is how we could create a program that would be able to accept, let me say, bowling stats. So your program going to accept the amount of balls that was bowled in a match or something like that. Shouldn't be the amount of, let me say the amount of overs that was bowled by a particular bowler, how much runs was scored and how much wickets were made. And it should be able to output the regular cricket statistics like economy and things like that you're going to be able to see. I know that one other group member was working on a store scenario, right? You could create a program that could calculate various types of commissions, right? So like let me say for example, you have somebody selling something, you could, let me say regular employees, if they sell and they make about let's say $5,000 in sales or something like that, you get them a 1% commission, which is kind of smaller. But if they sell like $10,000 in sales, you get them like a 15% commission on all the sales that they make. All right. So that's our next scenario. So you really have to think about your situation and how it applies to you. I know I had another group who was working on like let me say a bakery. I do expect them to do some sort of let me say billing system, like you can enter an item, or a set of items that and you'll calculate a total bill from it, right? So for our stuff, I had to make sure that how we, I can't let nobody cheat off of me, right? So I'm gonna solve a real obscure problem that seems stupid, right? So my idea for solving a problem, and I already see this before, would be to find the quotient of two numbers. The quotient of two numbers, A and B, is really A divided by B, right? We see this already, but you're gonna see it in the context of if I had to phrase it in the form of SBA. All right. So I'm gonna say it again. This video really important for you to watch. Even though it's gonna be long, gonna be like a whole half an hour or something. A whole half an hour. Yeah. It's gonna make a whole half an hour. Yeah. I want you to pay attention to this and I want you to see it through, right? So we're gonna reach it to how far we can reach it. So the first thing you're gonna have to show to your programmer is your problem definition, right? Alright, so I'm going to make that entire heading, and while I'm at it, I'm going to go ahead and make an automatically generated table of contents here. I don't like how this thing popped in like a heading like that's normal. Alright, insert, references, table of contents, automatic table. So at least I see my heading so far. So for my problem definition, I will say a program is required. And this is what I really telling my examiner what I'm doing here. I'm telling my audience who are going to read this document. A program is required by a math teacher to determine determine the quotient of two numbers. The program must output output the quotient, and whether, I think I spelled whether wrong, whether, oops, is we at her, right? I guess what I guess. Output the quotient and whether the number is very close to 0. And in maths later on, you're going to learn in A-levels, you're going to say that how you know you're tending to 0. A number is considered to be close to 0 if it is less than 0.01. Alright, so that's my idea. Alright, so this is my way I'm going through this here. Programs required by a math teacher to determine the quotient of two numbers. The program must output the quotient and whether the number is very close to 0. A number is considered to be close to 0 if it is less than 0.01. Normally, in the normal state of things, we would have jumped straight into doing a flowchart where we you could write it out, I could write it out in pseudocode if I want. I could write it out I could draw out a flowchart on a piece of paper. And of course, we're using our textbook and we're guided by our textbook, right? It's a great textbook by Howard Campbell, has always said that he really do a good textbook, everybody. But since we're using Flowgridim, I decided I'll show the approach using Flowgridim. So I'm going to start a Flowgridim, F-L-O-W, Flowgridim. So good best practice, go ahead and save your work one time. So file, save as, solving and programming. I just using the arbitrary name. I guess I ought to choose a name. I'm gonna put this in my home file folder. Right, cool. So this is a little cheat here that I'm doing. So pay attention to this part. I'm gonna make copying and pasting from the program into what you're doing a little bit easier, right? Now you don't have to do this. You can go ahead and create your program straight from here. Alright, so the little cheat that I'm doing here, I click in the function manager and I add in a function called start. Alright, and I'm taking no parameters and it returns nothing. Alright, and I click done here. I end up with a situation where in the function start. So I can see I have a main function here and I have a function called start, right? Now we didn't learn functions or anything like that, so right now what you do, you just follow in straight from me, right? So if I click back over here, I'm gonna go back to the main function. Alright, I could do a function call. So you go just be copying me call, and I'm gonna put this function name start. So I make it call start. If I go back to the start function, I'm just gonna put output statement just to make sure things working. Output something. Hello world. And I put the situation. So let me see. When I run my main function, Flowgridim is always start running from your main. If I click run, I will see print out hello world. If I step through it, I will see what really happened here. Main came into existence, and then we went into the function called start, and we output hello world. And I do all of that. I do all of that just to show one thing. I want to be able to, like, when we finish here, that we could just, let me just stop this here. When we need to show our flowchart, we can just do a screenshot of this. So I can just do a little screenshot like that. I don't finally see the screenshot. So it's snipped to the clipboard, and when I come back to my SBA, I can paste it over here. So you have an idea how easy it is to copy and paste into your flowchart section of your SBA. Alright. So let me pause it because I'll show a flurry of things. You can pause the video if you need to look back at it ever. Let me go back to over here. That's what the window that I had open. Let me pause. Do you have any questions about what I just did? It goes above and beyond the Call of Duty that you're required to do. And you're not required to do it. I could accept if you just go and use Flowgridim just so. Any questions? I think. Alright, so everybody looking clear so far. We're not even listening to the video, so let me see if I could pick up some speed here and start to make some progress, right? So we always think about things as having an input, processing, and output, right? So let me just it's a good practice to follow that sort of top-down stepwise refinement. I'm just gonna go over here. So number problem definition. Just before my flowchart, I'm gonna put something called IPO table. And we all know what that is. And if you can't remember what it is, as soon as I start to show the stuff here, it will become immediately apparent, right? So I'm going to insert that table. Does look like this. IPO stands for input, processing, and output. I'm going to be true ninja star here by bolding this stuff. Alright, and this is me thinking out loud from a problem definition. I can tell how I need to input two numbers. So I'm going to put, for the input part, two numbers. I'm going to call them num1 and num2. Num1, num2. We're processing. I'm going to put result is equal to A divided by B. Oh, I'm sorry, num1. I put num1 and num1 by num1 and num2. Num1 divide by num2, and I know find if result, and this is me thinking out loud. It's not like no special format here. That's what this IPO table is for. Find if result if the result is close to 0, and my output is two things. So mentally, let me just put a bullet point system here. Mentally, my output is two things: the quotient, well, result. So I know result was the quotient, and the next I want to output whether. I spell whether wrong. I spell WH. Lord, it's real embarrassing way. WHE, with, right? I'm losing my spelling skills as I get older, yes? Whether or not the number is close to 0. So, and as I'm thinking out loud here, find if the result is close to 0. So that's going to say if result is less than or equal, less than 0.01. All right? So that's my thinking here. So I know I had two things. I'm going to put a bullet point here because I know it's 2 bits of processing that I'm doing here. I'm going to do that there. I'll look at each chat right now. I'm going to find out if I have any questions. Just waiting at 10 seconds just to see if anybody have any questions. Nope. I think people good. All right. So that being said, mentally now I know what I'm going to be working with. This IPO table has really helped me to do that. So I know it's kind of like allow for me to create a checklist of the things I need to do. So the first thing I need to do is to input two numbers. To input two numbers, I need to create two variables to store the numbers, right? So let me go and look at my logarithm. You know, under the function start here, I'm gonna put a declaration. I'm gonna make num1, which is an integer, and num2. Somebody type in the chat for me. Is my screen visible enough for you? Can you see what's going on my screen? All right, good. Yes, that's great. So I know I'm gonna use num1 and num2, right? Another thing, I know I might need more variables to store data. All right, I could go back to my IPO table and discover this. So I'm gonna know that I know that I need to store a result here. All right, so what I'm gonna do, I'm gonna put my results. I'm gonna put result here too. Is in lower caps, and I know that I can't use integers because if you do 3 divided by 2, the answer is 1 because it's getting integer truncation like we discussed before. So I need to use real to allow for decimal numbers or to use decimal numbers. Otherwise, I'll be introducing a logical error into my program. All right, so I know I have my 3 variables here. The idea is input, processing, output. So let me go ahead and get the input, right? So for now, I'm just gonna output to the user. Enter the first number. All right, so then, oops, I had to put it in quotes. All my strings had to go in quotes, right? It might be looking small on your screen, so I put enter the first number, and I can always run it just to see how things are working. So I've seen that it's working so far, right? So enter the first number. I'm gonna go back to my start function, right? Enter the first number, and I'm gonna put input num1. My bad. Input num1. All right, and then I'm gonna tell the user enter the second number and input num1 again, num2. Sorry. So to do that, I'm just going to select it because I know it's similar stuff. I'm going to right click, I'm going to choose copy. I'm going to click the arrow over here and then choose paste. So I have that stuff there, but this time I'm just going to edit it, enter the second number. Okay, input num2. And it's always a good practice every bit of working code that you implement, try to see what happens. So let's change my layout here to variables and console, right? So all I'm doing is I'm running the program right now. I see my variables set up in memory and RAM on the right hand side over here. They ask me, I see the output screen, enter the first number, we reach where the program waiting for me to input number 1, and that's number 5. Press enter. I see 5 is stored in num1, right where you see my mouse is. And they ask me to enter the second number now. I'm gonna put 6, or sorry, 6.3, just to make sure that how I can store decimal values. Press enter. Now it kind of went out of existence here because the program stopped running, but it would have been stored into that variable there. So far I'm pretty sure my program running good. Going back to my start function, and let me write out the rest of the program. So it's kind of simple, right? So the processing also, I just gonna put over here, in my mind, I don't know if you're gonna be able to do this in your program, get data from user. Alright, and so the next stage for me, it kind of line up that I'm doing processing. So I put in a comment, stage. As I say, not everybody gonna have the luxury of being able to having their program looking like, you know, input, processing, and output, right? So what you can do, I need to find the quotient, right? So I need to put an assignment statement. So I set in result is equal to a, sorry, not a, num1, say num1 divided by num2. Alright, 17 minutes into the class, let me see if I can pick up some speed here. Alright, result is equal to num1 divided by num2. Even though I know I had the next part to finish out here according to this, I want to test out how I was able to do this thing successfully. Alright, so I'm going to output the result one time here. Later on, I'll come back to my code and I'll implement this part over here. Alright, the second bulleted point. So I'm going to put, I'll put a comment here, output results. Let's put output quotient. And using documentation is a way of really just informing the reader of your program what you're doing. You know, it's help our programmer to understand what you were trying to do. Alright, so I'm gonna put output. I'm gonna put output, and I'm gonna put the quotient is colon space. So I have to put that in quotes. And when we're doing string concatenation, which is basically adding onto a string, you'll be using ampersand sign in Flogorithm. So ampersand and result. Okay, so I'm gonna go ahead and run this program, and I'm gonna try to test and see what is up when I try to divide 6 divided by 5. So I changed it up a little bit here. So enter the first number 6, press enter. Enter the second number 5, press enter. I see again the quotient is 1.2. Alright, so I'm pretty sure it's working for me right now because I kind of know I can do that maths in my head and figure that stuff out. It's remainder 1. So 1/5 is 0.2. So I know that how is 1 remainder. Well, so 1.2, sorry, my bad. Alright, so I know at least that part working here. Let me go back to my start function. Let me go back to, I need to find out if the number was really, you know, 0, sorry, close to 0, whatever it is, right? So what I'm gonna do now, I realize I can't really just store it in the processing stage that easily. So I just gonna do the program however I can do it. So now I'm just gonna put a comment. I'll let my user, I'll let my program, the people who read my program know, find out if the number is close to 0. I'm gonna put an if statement. If result less than 0.01, do something. If it's true, I'll put this is very T0. Alright, so I'll put that. Otherwise, if it's false, I'll put I could leave nothing, but you know, I don't find that's a good idea. You must always give a user feedback. I'm gonna put the number is large. All right, so I'm good to go there. Let me go ahead and run this program and see if it's working. Right. So this time I'm gonna enter 5. Press enter. I change it up here at 6. So whatever 5, 6 is. And it says the quotient is 0.83333, and it says the number is large. Let's try to create a scenario where, so I test my program right now. Let's try to create a scenario that the number is sufficiently small. Alright, so how would I do that? I'll have to have a large denominator if my maths teachers teach me correctly. So I'm gonna try putting like a number like 6 and a very, very large number. I try 500,000. Alright, so I get an answer there, and it says the number is very, very close to 0. So that's kind of cool for me. So what I can do now is I can go back to here, my start function. I'm going to try to zoom out a little bit here. So that's all my code here. So all my code kind of like not fitting. So if I do a print screen and I try to print it, you know, because this running code actually is my flowchart too, because it's both a flowchart and code, right? So I'm going to copy that, and I'm going to go and put it in my Word documents. So after my IPO table, I'm a flowchart. I'm going to delete this old one. If I go to paste it from program code, I go and see. Well, actually, it's visible enough. It's visible enough for me to see it. All right. So I know that how my audience can read it. But most likely, your program that you write in mightn't be as visible. So I'm going to try to emulate a situation where it is not as visible, right? So I'm going to delete this. I'm going to go back to my algorithm code. I'm going to click save just to make sure. I'm going to zoom it back a little bit like this. Then pretend you can fit everything on the screen, right? What I do is I take screenshots bit by bit. So pressing, you know, in your case, you can press Windows key Shift S. That's been a stepping tool, and you do this. All right, you copy all that you can possibly copy. All right, when you do that now, and you go back to your Word document and you paste it, you basically paste piece of the flowchart, right? Let me just zoom out a little bit here just to show you what it looks like on the page. I'm gonna put this program code on Control Enter, right? So I'll put it like that, and I know the code had to continue, so let me scroll along and continue that code. So let me go back to here. So I know I reach just to the bottom of input num2. Let me go down, see if I can get the rest inside it. Oh, look, it kind of work out. Kind of. Let me zoom it out a little thing. All right. And I'm going to do a Windows key Shift S on my keyboard. And try to get a screenshot looking like that. So that's saved to my clipboard. Go back to my document. I know that how I can fit it on this page, so let's make sure I can move my cursor. Press enter here. Press Control Enter to go to the next page. Press Control V now. Alright, so here's an important thing. Anytime you have a flowchart going from one part of one page to the next, you have to use that terminator symbol, right? Now, my advice to you is to insert a shape. So go and insert through shapes. Really and truly is a shape that's a text box. You want to use a circle, but really I think, what is that, circle or oval? So use that oval and draw it at the end over here, right? Double click it and park a letter in it. So put like A. Alright, so I'm gonna make this font a little bit bigger. So I'll select it, go back on the home tab, change the font size to about 18, somewhere around there. Let me go bigger. Alright, that's too big. 26. So that's looking good for me. So I know that my terminator symbol A, it means that how go to the next page and continue from where you see A. So I can right click and copy this now. I go in here, I just right click on this page here. Let me see if I can paste it here. Right click paste. Alright, and then I'm just gonna move. I think he went behind. Alright, so that's gonna move him in place. Yeah, so my people could know. I don't know why the color of the font changer. Like whatever, man. I guess I'm gonna change back to a consistent. Let me copy back this A here. Control C, Control V. Okay, it's dark for whatever reason. Let me make this one dark too. Yes. Change that to not the font color, make it, yeah, make it that. All right, cool. So your code could run from one page to the next, you know, and the next page to the next. You might have a A, a B, and a C. But the important thing is that your algorithm is used to communicate to a programmer, so that how they know they could look at your algorithm and go ahead and implement the same code. We're just lucky in the case that our Flowgorithm just happens to be a graphical programming language, all right? So I solved the problem there. I know the problem. I know it have a error in it, right? I just want to scroll down here in my document. Sorry, I paste this in the wrong place. Wait, I also place this in I also paste all of this in my flowchart section. Sorry, lad. Let's change this to flowchart, yes. Alright, I'm gonna change that to flowchart. I'm gonna try to select everything from here all the way down. Alright, I don't know what happened. I press Ctrl Z. Apparently I deleted all my data for some reason. Go ahead and go all the way to the end here. Shift, Ctrl X. Okay, I think I've fallen apart on all the fellas right now, but I think I'll get the idea. Anyhow you take it, the flowchart and the pseudocode gonna be the same, and the code itself gonna be the same thing. Alright? So what you're gonna do, you're gonna paste this in your flowchart section and your code section. So let's call this code. So this is where it was before. For your program execution, you want to show the program in a test run to prove to the examiners that your program actually works. So you can just do a test run. In my case, it's real simple. I could just do one test run here and just take a screenshot of this. Alright. 5 and 1000. Alright, and what I'm gonna do, I'm gonna take a screenshot of this. So they gonna know that okay, cool, I run the program actually did run and things like that. So when I go back to over here now for program execution, I have that. Alright. So I have a problem to show my pure table, my pseudocode. We're not gonna come to the trace table today. I'm just gonna do an introduction into what could happen for the trace table. I want to do it in our next video. I don't want this video to be too long. It's already tending to be 27 minutes. Alright. So what we're gonna do now is what I'm gonna do now, I'm gonna close off on how to do documentation, and I'm just gonna show something else that really is a problem for my trace table, for my code actually. Alright. Some of you might already know what I'm gonna do. I'm gonna run the program again. If I enter the first number as 5 and I enter the second number as 0, I'll get a divide by 0 error, which means that how I need to go back now to my code and modify it. Another thing too, CSEC expects us to use looping. Alright. If you look at the mark scheme over here, I'm gonna go back to. So the appropriate and logical use of selection and looping. So you again one mark for looping. So we had to implement looping somehow. I'm gonna show you how I'm gonna implement looping, right? And this is gonna be a template that everybody could use in their programming code. Most of the time you won't want to just run the program once, right? So to solve that problem, I'm gonna go back here. Now I know I run into an error. In the next class we're gonna look at how to solve that error. I go back to my start over here, and what we're gonna do is this. I'm gonna implement a looping situation. So I'm gonna add an X variable inside here. Declare. I'm gonna let it be a string. Alright. I'm gonna put confirm. I like to use it with confirm. Alright. I'm gonna put while here I'm gonna put output. But would you to perform a calculation, calculation dot. Would you like to perform a calculation? And I'm gonna say while confirm equals y. Yeah, we'll put in common because y do these things. Oh, I didn't get the confirmation from the user. I'm gonna put input confirm. Usually you see that when you prompt user is always how to get the data for the variable. Alright, while confirm is y, we're gonna do some things, right? And generally speaking, you always have to kind of perform this step again at the end of our while loop. So I'm gonna copy this stuff here, right click copy. Now remember, all you can always pause back the video and thing and watch back this thing here. So I'm gonna paste it inside here. Would you like to perform a calculation and put confirm this? I'm gonna call this another calculation. ANOTHER. Alright. So I'm implementing loop in here. Alright. So what I'm gonna do, I'm gonna zoom this stuff out, and all the rest of the stuff that I want to repeat, I'm gonna make sure and select it all, make sure I light in blue, right click, choose cut this time. I'm gonna right click here now, or click, you can click or right click and choose paste. So now I have all this logic happening inside of my loop here. So even if you don't understand it, let me just see what happened here. Let me see what was implemented. If I go to run this thing now, I'm gonna see it asking me, would you like to perform a calculation? Let's make it bigger so I can actually see it. If I type anything but y, let me say I type that, and I press enter, the program will just end. Alright? If I run the program again, so I run it again, would you like to perform a calculation? I type in y on my keyboard and I press an enter. Then it takes me through the logic. I can put 4, and I can put 5. I will see the quotient is 0.8, the number is large. Would you like to perform another calculation? I can type y again. I can do 7. Then the second number 1000. Quotient is that. The number is very close to 0. Would you like to perform another calculation? And this time I didn't enter y, you know, and the program ends. So the only thing I really had to do here, oops, some things. Did I close the program? Okay, cool. Let me make sure. If I go, so all I have to do here is just power message saying exiting, output exiting. Dot dot dot, and that's about it. Alright folks, so obviously I would have to, every time I make changes to my program code, I'm gonna always have to go back to my document and update it. Alright, this is one of the pain points that you're gonna have when you're working on your program, but by using Flowgorithm, we go see it's just screenshots that we have to update. And remember, Flowgorithm is also giving the ability to see what the pseudocode could look like. So if you want to understand if you prefer working with pseudocode, you could go ahead and where's the tools, source code viewer, and you can choose different standards of pseudocode that they have here, or you can even choose Pascal code, like actual Pascal programming code, and you can run the stuff in Pascal, you can run it in Python. I know this boy was doing Python, Darren Das was doing some Python, so it actually write the code in Python for you here. I don't really want for it to be doing this here, because we say we're using pseudocode. You could use IB or pseudocode. I think that's the one I used. So it's giving me an idea of what's going on inside here. Alright, so that's if you wanted to use pseudocode, you can select this, and you can always copy the text. So like when I click that button, it says, let me show you the button again, this button here, copy the text. So if I open, you know, if I really wanted to have a situation like that, I can go over here, you pretend that you use pseudocode instead, Control V, I have my algorithm written in pseudocode. Alright, my only problem is I gotta go and edit it because it has functions, and functions is beyond the scope of what we're doing here. Once again, the reason why I created the function at the start was simply to just get a start and stop when we create the flowchart itself. Alright, that's all I have to say about that. It was a lot, but we had a lot of prerequisite knowledge going from Form 3 to now. Alright, let me pause for our course and find out if anybody have any questions about what I just now do, or if you would like for me to re-demonstrate any of the items. And give me some audio feedback now. Tell me, you can tell me a little no, you can tell me a little yes, that kind of thing.
So we'll watch the videos, so we'll probably be able to follow along by that.
Yeah. So let me see. Unless Sandy's still here, boy. Sandy here? Yeah, so when you watch back the video, you just skip through the video and stuff like that. You skip through all the boring points, right? If you need to look back at it, right? The other class today, they will. I'll tell them to watch this video to entirety because it's essentially a repeat of what we're doing. What we're gonna do is set the expectation for the next class. Next class, we're gonna look at how to manage the trace table. All right. So there is going to be some asynchronous homework for us tonight. I really want for you to go and revise the section on testing. I think I had already posted in the classroom. I'll just verify that. Testing algorithms. Yes, I posted it 9th of March. That's a few days ago, right? So definitely for the next class, please read this material here, Information Technology for CSEC 3rd edition, pages 276 to 278. Excellent textbook. I can't thank Howard Campbell enough for writing this textbook. This textbook really making my life a little bit easier. The only thing that you have to do is actually read it so we could actually go through the material and we could actually see how I'm going to approach implementing my trace table using Flowgradam. Alright fellas, if you don't have any other questions here, this video is about 35 minutes long. Thanks for tolerating me through this period of time here, because I know how hard it is to follow along with somebody in this video stuff here. So I appreciate the effort. If you don't have any questions or anything like that, I'll go let fellas go. Alright? Okay then. Bye.
Alright, thank you.
Hey, thanks man. Bye.